Okay, good afternoon, dear Simone, dear project partners and all participants. Welcome to our sixth webinar of the Erasmus Plus project 3D STEAM with the title Accelerating STEAM-related knowledge and skills via 3D modeling and 3D printing. Our speaker today is Simone Jablonski, a junior professor at the University of Paderborn in Germany since 2024. She completed her PhD at the Goethe University in Frankfurt in 2020 with the subjects mathematical aptitude and mathematical reasoning. As a postdoctoral researcher, she worked on various representations in mathematical modeling, including outdoor mathematics and 3D printing. She completed her habilitation in this field in 2025. Let's welcome Simone with her presentation entitled Exploring the Potentials of 3D Modeling in Mathematics Education, Insights from Two Empirical Studies.
Yeah, thank you very much for this nice introduction, Yves. And I'm very happy that I got the invitation to speak a little bit today about my research and the findings that I got in terms of 3D modeling and printing. So thank you for being a little part of your project. And I hope that we will have some nice insights today. So I have to click now. Yeah, now it's working. So what I want to do with you today, first of all, give a short introduction of what I would say my background of modeling is. So because I'm from mathematics education, and that's why I want to give you a brief introduction of modeling in STEM education and also the role of mathematics education in that. Based on that, I will show you the two different perspectives I want to present today for 3D modeling. So the first you find in study 1, which is the modeling through working with 3D printed objects. So for example, like a sculpture that you'll find in your nature. And the second study then focuses on products that students created and also printed, which is about a famous building in Frankfurt, but we will come back to that later. So actually, modeling in STEM education, I'm sure that you heard in the other webinars a lot about that maybe, but why I chose modeling. So when we speak about STEM education, we can define it as an interdisciplinary approach to learning where rigorous academic concepts are coupled with real-world lessons as students apply science, technology, engineering, and mathematics in contexts that make connections between school, community, work, and global enterprise. So this is the quote I want to refer on in the following, because from my experience, modeling and making connections is something that links all the STEM disciplines. So it is something, the connection between our STEM disciplines and the real world that comes together when we focus on STEM-related activities. That's why we also find it in the STEM curriculum, which is about developing and using models as one of the activities being written there. So we have some shared aims when it comes to STEM activities, which is the integration of real-life situations and objects into STEM education and to foster motivation and sense-making, like showing students where in reality we can have a meaningful activity related to our STEM subjects. And as I told you, I'm originally from mathematics education, and my research also focuses on mathematics education. But I think we can reason that it is also important for the STEM activities in general, because applying and modeling is a central mathematical skill that we need for future society. And we have a significant role of the development and application of mathematical models in STEM-related work context. So mathematical models are not only relevant in mathematical tasks, but also in the STEM-related works. And we have an important role of mathematical representations and patterns, for example, diagrams and so on, in many STEM modeling activities. And just for you, maybe you know it, the mathematical modeling cycle from Bloom and Lies, which is something in my subject that we refer on quite frequently. So the idea is to describe these modeling processes. We have like, let's say, two worlds, or they call it two worlds. On the left-hand side, the reality, and on the right-hand side, the mathematics. So one can discuss whether mathematics shouldn't be part of reality, but actually to idealize it, they just distinguish these two worlds. And what they do, they say, okay, a modeling process starts usually in a real situation. We have to understand it, and we have to simplify it, structure it. And then this is step 3, it's about mathematizing. So bringing the reality to the mathematics so that we can work mathematically with what we have. We can interpret the results, validate them, and present them. So in the best case, we use the results for anything that is relevant in our reality. And with this very short introduction to my understanding of modeling, I brought you these two perspectives for the talk today. So I will start with modeling through working with 3D printed objects. And then I will continue with modeling through creating and printing 3D objects, which is done by the students. So my first study focuses on the work with 3D printed objects. And as an introduction, I brought you a very, let's say, typical example of how modeling tasks can be brought to the classroom, which is, at least in Germany, quite popular because it is just a picture here, in that case, of a potato. And we have a short introduction how you make French fries out of this potato. So there is a little bit of text, how you do it, that they all have nearly the same length. And it says, okay, the potato in the picture should be about 10 centimeters long. How many complete French fry sticks do you get from a whole potato? Give a mathematical reason. And this is an example how you can bring references to reality in the classroom. But we also know that students might be overwhelmed with such a task, especially in the first attempt when they don't know, okay, it's a very open task and I'm allowed to do assumptions, I'm allowed to do estimates. And what happens then is a strategy that says, okay, I don't know how to solve the task. I just ignore the context. I don't care what the task is about. Take all the data from the text and calculate anything using a known scheme. And when we think back of the motivation for modeling in the STEM activities, we see this strategy is maybe not the best because we want to show the students where in reality we find a meaning for STEM activities and the other way around. And if we ignore the context, it's not very useful for our goal. So that's why I decided to focus in my study on students' modeling activities when they work with real objects in different settings, like the potato, but different ideas of representations. And so you already know this cycle now. The different representations come from the presentation of the real situation. This means when I want to focus on a real object in a task, I have different possibilities to use a representation. And I did a short literature review on that and found that we can see, for example, text, newspaper articles where a real situation is described. Or we can see photos like in the potato task that gives us some idea about a real object. Or we can describe it via a video, so like showing us from reality what happens here. We can also use 3D models so that we have like a short representation or a smaller representation of the real object and bring it to the classroom. And one thing that's a little bit beside is we could actually also leave the classroom and go to the real situation and the real object and experience outside. Of course, only if it's possible to visit this location without too much effort. So in my study, I decided to focus on geometric objects. And that's why I only focused on photos, on 3D models, and on leaving the classroom and visiting the real situation or the real object. And what I brought as earlier research findings for the study concerning photos, we know that it helps in supporting the modeling steps, especially understanding a real situation when they represent the actual situation. So it might be easier for students to understand what the task is about if I bring a photo. But on the other hand, it can be confusing because a three-dimensional situation or object is usually represented two-dimensionally. So we have this shift of perspective in here. For the 3D models, I have to say, when I did this study, it was usually used in the area of creating and printing. So most studies focused on students doing a 3D model and not so much about teachers bringing it to the classroom for do modeling. But I knew from one study, it said that we already have a simplification of the representation and examination of the model. So when I bring a 3D model to the classroom, it's already a little bit simplified in comparison to the model, to the real object that I found in reality. And concerning leaving the classroom, so we know that when students are allowed to leave the classroom and experience the real object in their reality, this enables mathematizing real-world problems with a particular focus on the data collection, so that it is quite important for the students, or it has a lot of variety in terms of data collection when I go outside. It does not have a significant effect as a context of students' interest and enjoyment. And hypothetically, it evokes different modeling activities, especially when it comes to simplifying and structuring and mathematizing. So with these earlier research findings in mind, I asked the question, to what extent are differences in the modeling activities observable with respect to different settings? And what I did in between 2021 and 2023, I conducted a study where I actually focused originally on the outdoor mathematics context, but the 3D printing is part of it, so I will focus on that today. And I had a sample of 29 secondary students, grades 6 till 8, which is in Germany about 12 till 14 years old. From an extracurricular enrichment program, which is called Junge Mathe Adler Frankfurt. So the students can be described as mathematically interested and potentially gifted. So there might be a positive sample in that. As a survey instrument, the children were divided into groups of 3, and I did video recordings of them solving 3 different tasks. One outdoor task where, as you can see in the picture, they went to the real object. One indoor task where they got a representation in form of a photo. And one indoor task with a 3D model. So I had an arrangement of the groups in a Latin square design, which means that I arranged different orders in which the students solved the task. And after each task, I gave them a questionnaire with 13 items where I focused on things like interest and enjoyment, relevance, real-world connection, simplifying structuring, and mathematizing. So for the data analysis, I worked with so-called modeling activity diagrams, where you can see the different phases of modeling. And I conducted a qualitative content analysis concerning the steps simplifying and structuring, mathematizing, and for the questionnaire, I used the one-way ANOVA and post-hoc tests. So these were the 3 objects I used in this study. The left one is a stone, which is very close to the university. It's a very heavy stone, as you can imagine, and we asked the students to calculate the mass of the stone. In the middle, you can see an architectural sculpture, which has, maybe you can see the scones. It is called rotazione, which means because the spikes, they actually rotate around it. and the students should answer a question about the surface of this sculpture. And the last one, the third one, is called Body of Knowledge. It's a sculpture at our campus, and it's not so easy to see it from this perspective, but it resembles a person and the knees are bent to the body. So actually it's a sitting person, and the students were asked to say how tall the sculpture would be if this person would stand up. So we have like 3 geometrical tasks, one about volume or mass, one about surface, which is area, and one about the length. And for each of the objects, I created 3 different settings. So on the left-hand side, you see now the real object setting, where the students were allowed to go outside. They had measuring tools with them, and they solved the task directly in the situation of the object. We have the photo setting, where the students received 3 different pictures from different perspectives of the object, together with a person as a reference, a person of reference, so that they could do some estimates about the length. And finally, we have the 3D model setting, where all the objects were scanned and rebuilt. They were printed and given to the students together with a Lego figure, so that we again had an object of reference here. For the questionnaire items, I used the 4 different categories. For task-specific interest and enjoyment, I used a scale by Hartmann and Shukayov, which said I found it exciting to solve the task, for example. Relevance and realism, where we wanted to see whether the students recognized a connection to reality in the task. Simplify and structure, which is a direct connection to the modeling cycle. So for example, I found it difficult to distinguish between important and unimportant information. And mathematizing, something like I had no problem selecting and collecting data, which mainly focuses on the data collection process. So coming to the results, I brought you an overview on first hand. So this is one of the modeling activity diagrams I produced during the study. It shows the solution processes of one group. And you can see they worked on the stone task outside at the real object. And you can see how much time they needed. And the different colors represent the different phases of the modeling cycle. After that, they solved the sculpture task with the photo setting, and finally the body of knowledge with the 3D print. And what you can see here is, for example, with the 3D print, they started understanding. Then we see a little alternation between simplifying, structuring, and mathematizing, having a little bit of mathematical work, and then going later back to simplifying and structuring. So you can follow a little bit the approach that the students had, and we see in none of the cases it's this ideal cycle, but the students jump from one of the steps to another. So when we have this about all the different groups working on the task and the different settings, we can see how much time on average they spend in which phase of the modeling. And we can see for all the 3 settings, it's the simplifying, structuring, and the mathematizing where the students spend most of the time. So when you remember the modeling cycle, it is mainly what happens in reality when they have to distinguish about important and unimportant information, and when they do the data collection process in order to bring it to the world to mathematics. So both of these are the most discussed items by the students. And that was the reason, or maybe going back, that was the reason for me to focus on these 2 phases in more detail in a qualitative content analysis. So for simplifying and structuring, I started to analyze the discussions of the students, and I found 3 relevant categories of what they are doing in this phase. So the first one was the analysis of inaccuracies on the real object. So, for example, in this quote that I brought, the students worked outside at the stone, and they said something like, the surface of the stone is completely uneven. Maybe you need to remove something. So if you remember the picture, you saw, okay, the shape is not very close to a cuboid. Of course, we can model it like that, but we have to think about what are we doing about the uneven shape. Then we have something like discussion about the appropriateness of the model. And here the students worked with the 3D model of the stone. And they said, I don't know if we can simply say that it's a cuboid. If so, then we should say that there are two parts, one at the top and one at the bottom. So actually the students start to think about, is a cuboid, in that case of the stone, appropriate to describe it? Or is it too simple in comparison to reality? Do we have to maybe say like, okay, there are two, a big cuboid and a smaller cuboid, to like describe the model in an adequate way? And we have a discussion about the availability of data. So here students worked outside with the body of knowledge, the person sculpture. And it said like, we don't know the height, but we can't measure it either. So like they said, okay, we could actually do that, but the sculpture is 12 meters high in its original form. We cannot measure it directly. What should we do? Like saying which data is available and which not. So when we see the 6 different groups that I analyzed for this qualitative content analysis, you can see how many of the groups in which setting use this category in their discussion. So you can see, for example, for analysis of inaccuracies that happened in every group outside, in every group of the photo setting, but only in 3 groups with the 3D model. And so you can understand this table. So my results for working or modeling with the 3D model. The analysis of inaccuracies seems to be less important. My hypothesis in that case may be because it was already simplified when we did the 3D printing process of these real objects. The second category, the discussion about the appropriateness of the model, is similar to the work with photos. And the last category was a bit surprising for me, but then I started to realize, yeah, maybe it's not so surprising, because there was no discussion about the availability of data, since when you have a short 3D model like this sculpture, which in the original part is 9 meters high, and you bring it to the classroom in a smaller version, of course you can measure all the data. You can measure like how tall the sculpture is, and with the Lego figure together, you can use a bit of scaling and then have the original height. So that's why the students didn't spend any time about a discussion about available data, in contrast to being outdoors where the objects are quite high. And here I want to make a reference to interdisciplinary STEM activities, because the findings, in my opinion, are not only relevant to mathematics, or we can easily transfer them to STEM activities, because the choice of relevant data from reality requires particular structuring. So this step is not only relevant to mathematics education, but I'm sure that we could also transfer at least some of these categories and some of these results with a 3D model to STEM in general. So for mathematizing, I also found 3 different categories. The first one is to make assumptions, like saying, okay, when I work with this Lego figure, or here it was with the photos, and I had this object of reference in the photo, and the student said like, okay, the person could fit 1.5 times into the height of the stone. So something like having an assumption about which brings me actually the height of the stone. We have the selection of data, and here students worked with the 3D model at the stone, and they said we can measure the small height once and the large height once, and then divide it by 2. So actually ideas about how I can actually collect my data, which is done in the last category. I do not have a quote here, but all the activities that in terms of data collection happened to bring a specific value that was used for the mathematical calculation later. So again, for the groups, we had the 6 groups, and you can see it's quite homogeneous in that view, except making assumptions at the real object. In all the other groups, all categories in the settings were relevant. And for the 3D model, the use of 3D model for the modeling process, we can say, okay, the idea of making assumptions is as relevant as in the photo setting, but there's a difference on the content-based level. Because in the photo setting, students had to make a lot of assumptions concerning perspective. So when you remember in the beginning about the research finding that pictures might be a problem concerning the 2-dimensional and 3-dimensional perspective, we can see that the 3D model does not bring this problem, but students discussed a lot about scaling. So they had to think about, well, actually, this is maybe like 9. So actually thinking how you get the original height from this representation. The selection of data and data collection is relevant in all the groups. Of course, there were different things. So for example, estimation was more relevant outdoors, whereas students had the possibility to do measures of all the data given in the 3D model setting. So we can see that the work with the 3D model particularly puts emphasis on mathematizing, like this transfer from reality to mathematics. And also here, I would say that this is transferable to the interdisciplinary STEM approach in the sense that the idea of data collection is relevant in STEM modeling independent of the discipline. Of course, there might be differences in the way that data is collected and which kind of data is collected, but I think that it's a relevant thing in all the STEM disciplines. So finally, before we come to the second study, I want to give you the results of the questionnaire items. So concerning interest and enjoyment and relevance and reality, students didn't report any significant differences between the settings. So they had actually a lot of interest and enjoyment and saw relevance and realism in all the settings. So actually the work with the real objects, independent of the representation, was something maybe new to them and interesting for them. And we could see significant differences in the simplifying and structuring and mathematizing when we compare the real object setting, so being outdoors, and the indoor setting with photos. So the students perceived, for example, that it was easier for them to distinguish between important and unimportant information outdoors, and that it was easier for them to do the data collection or not arbitrary, in contrast to working with the photos. But we couldn't see any significant differences of the 3 settings with the 3D model. So there were no significant differences outdoor 3D and 3D and photos. So my conclusion from that is that 3D models could be seen as a good enrichment of mathematics classroom activities because they combine like 2 things. The first thing is we can use 3D models to integrate real objects without the need to leave the classroom. So especially when you want to bring very famous objects or very tall objects that you cannot visit easily around your school or around the university or where you want to do the activity, then it's a good idea to create a 3D model and let students work with that, give them an object of reference, and then have in mind that students need to do the scaling in the end. And it enriches the work with photos, which would be an alternative to bring the real objects to the classroom. But we do not have this problem that the students had sometimes between the 2-dimensional and the 3-dimensional perspective that was discussed by them. So that's actually my practical result from this study, which puts focus on the 3D models as a good way to bring reality to the classroom. And that's the point where I want to focus on the second study, which is about students in a more active role when we think about 3D objects to create and print them. And this study was focused on a very famous building in Frankfurt. Maybe you know that. If you visited Frankfurt once, you know the skyline, and maybe you know this skyscraper, which is our fair tower. And it's quite iconic because of its shape. Because we have this pyramid on top, and we have very different geometric solids here, very interesting architecture. And my colleague Tim, from Frankfurt, he once gave me like a printed map from Frankfurt, and we identified the area and said, yeah, that's the fair center. And maybe you can see that the fair tower is only represented as a cuboid. And we were not very happy with that because it doesn't represent this iconic shape of the fair tower in the original sense. And that was the starting point for us to give this task to students and let them create a replica of the fair tower, like giving them the motivation. This is from OpenStreetMap, but we are sure you can do it better so that we have this iconic shape in the final result. So what we actually did with the students, we went through them following the 3D MP modeling the 3D modeling and printing process. So what we did, we had the luck that the fair tower is very close to university in Frankfurt. So we took some students and brought them to the location of the fair tower, and they were allowed to take notes and model the fair tower right on site. They, for example, noted the different shapes, they made some estimations about the height, and so on. Then we went back to the classroom, and students had to do the 3D modeling in Tinkercad. So I will show you this program later, but I'm sure you know it. So that they recreated the fair tower. We then prepared the 3D models and printed them, which was mainly because of time restriction. But what we did, we brought the final results to the classroom, and students had a chance to validate their 3D models and see what happened during the printing process. So again, when we focus on mathematical modeling in these steps, we see, okay, the first one is about understanding. When we then go outside and visit the fair tower, we focus on simplifying and structuring. So this is like notes that students took when they were on site of the tower. So you can see that they draw the different shapes here and made like a sketch, and also made a ground plan so that they know later on how to rebuild this model. And when it went to the Tinkercad part, actually the students had a chance to do some more calculation, like they had different levels that they defined. So this group did it like that. And they also noted their estimates for the different heights of each level. So this is a short video that Tim made from Tinkercad, and I'm quite sure that you heard about it maybe in the other webinars, but it is a very easy software where you do not need any programming skills, but you can just have different solids that you drag and drop in the working area here, and you can use the types to make it bigger or make it smaller, and have different possibilities to actually combine or to leave out certain shapes here. So that was, we gave the students an introduction of that, and it worked quite well to have a replication of the fair tower. So the left one, of course, is the original one, but then on the other side, you can see what the students actually did in order to create. And you can see that all of them, in my opinion, represent the fair tower in a recognizable way. So I think all of them, are quite similar to what the students should do, but you can see that they put emphasis on different details. Like, for example, the second group has these green prisms on the facade, whereas the last group has, for example, the staircase facade. So we see that there are many differences in how the students work with this program and what they think is important to rebuild the structure of the fair tower. And what we did in this study, so we started with the real situation, like the fair tower, and we came with a real result. We wanted to see what happens in between, actually. And again, here we focused on selected modeling steps when the students create a 3D print model of Frankfurt's Fair Tower. We had 11 students, about 13 years old. They had no previous knowledge in the field of 3D modeling printing. We analyzed the modeling products that the students had in Tinkercad, and we have an observation documentation of the work processes in form of the worksheets. And we analyzed that particularly in terms of the steps simplifying structuring, mathematizing, and validation. So concerning simplifying and structuring, we see, like here in the sketch that one group did to rebuild it, we see that the students decided, being on side of the object, what is important. This group, for example, said, we want to have this stair-like facade, but we think that the windows are unimportant. Actually, it would be very time-consuming to create all the windows, and they are not as relevant to recognize the shape of the fair tower. So they left out this information. What we see as well is the approximation of the tower with help of geometric solids. So all the groups started to use geometric solids without knowing Tinkercad beforehand to recreate the architecture. And we see a structuring process in this group when they started to define different levels. Like the first level, it has this solid, that should be about that height, and so on. Concerning mathematizing, we can see that especially heights and scaling are relevant here in preparation for the 3D printing. So on the left-hand side, you see the estimations from reality. And on the right-hand side, we told the students that it should, to be printable, the tower shouldn't be larger than 7 centimeter. So again, students had to do a lot of scaling in that and calculating from reality to the 3D print. And then concerning validation, we actually asked the students to validate before printing, but the most of the validation, as we knew later, happened after the printing. So when the students got back their product, we asked them what went well, and they answered things like, okay, we are quite happy with the size and the scaling. We think that the general shape is good. We do not have floating elements, and it looks realistic, so it resembles the fair tower. But what many students didn't do was to take care of symmetry. So that was something they only noticed after the printing process, even though Tinkercad has the possibility to show the object from different perspectives, also from above. Students didn't do that, only after the printing. They also said, some of the elements might be missing, so we could have focused on more details. Some students produced overhangs in contrast to the floating elements and a stronger focus on details. And what we did after that, we asked them to do first improvements in a revision of the modeling construction plan. Like, if you could do it again, what would you do differently? And what they did, all the groups added sizes to the sketches, which was not done by all the groups beforehand. And students added information about the symmetry, like add 4 of them in the center of the cuboid. So they actually noticed that symmetry is an important aspect when you want to recreate a nice architecture in that sense. And they also added some focus on details. So for example, make 4 holes at the corners rounded. So they actually wanted to have the edge more rounded up, for example, and added some information about that in here. So to summarize what I told you today, when we model or when we bring 3D printed models of real objects to the classroom, we can see that students focus on processes like simplifying and structuring. On the one hand, a 3D model is already a simplified representation of reality. On the other hand, we have discussion about the appropriateness of a model, since all data is available. So there's no restriction, as it is maybe in the outdoor setting, that I cannot measure all the data, but it is so that students are not like restricted in a mathematical model. The focus on mathematization is also there in terms of scaling. So students mainly discussed how they can bring their results in terms of height, in terms of shapes, to the reality and say how tall, for example, the sculpture is in reality. So to bring it to a point, we can say that 3D models bring the chance or give us the chance to bring real objects in the classroom without leaving the classroom and without discussion about perspective. And on the other hand, from the study where the students created their own 3D object, we see in terms of simplifying and structuring, it requires simplification of reality. So what is done in the first study by us, like creating, students have to do here in a more intense way, because they have to decide what is important and what is unimportant. And again, we see a focus on mathematizing by scaling. So again, we have this focus on scaling, not bringing it from the small to the big, but bringing it from the big reality to the small object that should be created. And what we can say about the validation, it happens only after the printing process, or at least in our sample, it happened only after the printing process. And what we have here is again something like you have the screen, you have the 2-dimensional representation on the screen, and in contrast to, you have the 3-dimensional print of the object thereafter. So what we did in later processes of the same activity, we gave the students the chance after the first print to work on their model and improve it, because it was something the students were a bit sad about and actually wanted to bring a very nice model home. So to conclude, again here I see a chance to foster differentiation, because you could see the different models have different grades of details, but all the students created an object that resembles the original one, and also in terms of creativity and modeling. And if you want some more information about the 2 works, I included 2 references here. And on the other hand, I'm also very happy to answer your questions, maybe now, or you can contact me via email. So thank you very much.
Thank you very much, Simone, for giving us this insight in the 2 studies you conducted. I've already asked our listeners on YouTube if they have any questions. No one raised their hand so far. Maybe there's one of the project partners here who wants to ask something. Go ahead.
Okay, you said that I will ask, and I always ask, because that's not because I must, but because I was interested. For example, you mentioned that they told you that they would change this and this, and they would work on this and this in this. The question is, could you try to do it in several steps? So second attempt, third attempt, and to make it better and better?
Yeah. So we didn't do it with the first sample where we did the study, but it was one result of our study that we gave them the chance to rebuild it. So, and then we printed it again, and the students were much more happy about their results in the end. So it is a good way to show the students how validation can bring process in their own modeling process. So yeah, that was an important outcome for us, that this revision phase is important.
Yes, and their own feedback, because they had some experience, they know how to do it. So
yeah, exactly. So they have more skills, and I think what was surprising for us in that moment was that they didn't do the validation on the screen. So we thought they would do it before printing, but after the first printing, and they had no previous experience in 3D printing and modeling, so they noticed like, oh, actually that's important. So they weren't like aware of symmetry being important to their model, but when they should take it home, it was like a bit disappointing because yeah, it's not so nice as we imagined like that. So I think that was an important skill that they learned through this activity about what are important things of 3D modeling and printing.
thanks.
Okay, so I see one question on YouTube nevertheless, so I'm trying to read it out. If you had to choose, would you rather have a 3D printer that's quicker at materializing the 3D models, or would you choose one that takes some time?
Oh, that's a good question. I think it always depends on actually the task or what you want your students to recreate. So I think for first experiences, it is very nice for students to see the actual 3D printing process and follow what the 3D printer does. So especially for the first attempts of models, I would recommend to have like a quick one where you also have give students the feeling that they are allowed to fail in what they do. So like a try and error maybe in that case, that you do not have the feeling, okay, it took so much time to print it, I have to like it now. So, but actually have the chance to maybe say, okay, that was not a perfect one, but we try it again with what we know now. And I think this is an important outcome of what students can learn about 3D printing. When they are more experienced, why not buy one that gives you maybe more aesthetic? But I would say in our studies, we do not have the perfect printed results, but the students are still happy about what they do because it's their own thing. It was recreated by themselves and they are proud of it. And I think this is more important than having a very perfect object in the end.
Yeah, I can only join you in this. So when we did it during the pandemic, we used a GoPro to film the printing, to be able to share it with the students because they couldn't print themselves. But I guess here the students were allowed to print themselves on, or did you print it for them?
We printed for them, but we showed them the process of printing one tower. So the problem was in the program, we didn't have so much time that we could print, because we wanted to print it for all the students, that every student had a model in the end. And we just decided to only print one model with them to show them how the printer is working. But the main work was done in between the sessions.
Okay, great. Any further questions for our speaker? Nothing so far, so I guess we will stop the stream here.
Mm-hmm. Yeah, thank you everyone for listening.
And